Number 25, determine the intervals over which the function is decreasing, increasing, and constant. And like we talked about in question 24, the technical way that we are going to define where this function is increasing, decreasing, and constant is to ask ourselves, what is the y value doing as the x value is increasing or gets bigger? And we read a graph from left to right, just like a book. And so if we start reading our graph here, as we read from left to right, we can see that the x value is getting bigger, and as the x value is getting bigger, so too is the corresponding y value, right? As we move from left to right, not only is the x going from -10 to -9, 8, 7, 6, so on and so forth, but we're also going from 3 to 4 to 5 to 6, and that trend will continue over the entirety of this function's domain. So we can say that this function is increasing from -infinity to +infinity. So over the entire domain of this function, we are increasing. At no point on this function are we decreasing, and at no point is there any constant interval. Now, just like 25, or rather 24, I showed you maybe a fun way to remember increasing, decreasing, and constant, and that's when I introduced you to Red, our little ant buddy here, our red ant. And we said that anytime Red is walking uphill, our function is increasing. Anytime Red is walking downhill, the function is decreasing. And if Red is walking on a flat surface, he's not going up or downhill, then that part of the function is constant. And so if we stick Red down here at the bottom left and let him start walking, he's going to start walking, and for the entire journey, notice he's going to be walking uphill, right? And so we can then maybe more visually see that this function is increasing over its entire domain. No matter what the x value is doing, as we read from left to right, we are having a positive change in the y. The y is getting bigger as the x is getting bigger, and so we are increasing from -infinity to +infinity. Number 25.